In this video, we'll walk you through the installation process of installing a Waterguard subfloor drainage system to provide your customers with dry, usable space. The basement system's Waterguard drainage system revolutionized the industry in 1994, and now there's millions of feet installed. Waterguard is an innovative, non-clogging interior basement drainage system with an integrated wall flange designed to effectively keep basements dry year-round. Waterguard is superior for many reasons. It saves a lot of labor compared to installing a traditional drain tile system. There is far less jackhammering, hauling of breakaway, and concrete mixing. Secondly, Waterguard has a built-in wall drain to also capture water seepage from the walls, unlike traditional subfloor drainage systems. Lastly, Waterguard is installed on top of the footing, unlike traditional drain tile systems. Traditional drain tile systems are installed in front of the footing, in what we call the mud zone, which makes the drain tile system prone to clogging. Water and dirt make mud, and as water moves through the soils to drain to the perforated pipe, it commonly will clog traditional drain tile. By installing Waterguard on top of the footing, Waterguard is out of the mud zone and will not clog. Waterguard collects water 3 ways: from the floor wall joint, the walls, and from below the concrete floor. Never install Waterguard with organic material behind it, as it could lead to rot, musty odors, or worse. Waterguard can be installed on concrete, block, brick, and stone wall foundations. There are 3 keys to installing a successful Waterguard subfloor drainage system. The first and most important key is to install the sump in the low spot of the basement floor. Larry Janeski's first and only rule of hydrodynamics is water flows downhill. The second is to get enough water out of the Waterguard system using a proper Waterguard drain outlet. This allows water to be unrestricted from both directions, ensuring the Waterguard system drains properly. And third is we backfill the Waterguard to the very top with clean washed stone. We lay Waterguard sheeting over the Waterguard and stone, then we concrete over the Waterguard system. Identifying the low spot. There are multiple ways to confirm the low spot. Ask the homeowner, when your basement leaks, where's the deepest puddle? Or where does the water dry last? Using a tape measure at the perimeter of the basement, measure from the floor up to the floor joist. Start in one corner of the basement and work your way around. Wherever the biggest measurement is, will be the lowest spot. The best way to find a low spot is to use a laser level. This way, we are relying on a self-leveling laser instead of the flooring system above, which in older homes may not be flat and level. Set the laser in the center of the basement and broadcast the beam onto the basement walls. Using a tape measure, measure from the floor to the laser beam. Mark all measurements on a sketch of the basement. As you work your way around the perimeter, turn the laser 90 degrees to project the laser beam on walls that you will be measuring next. The laser level can be on the floor or elevated if there are obstructions limiting the beam from reaching the exterior walls. The same is true for this method as before. Wherever you get the biggest measurement is the lowest spot. If there are interior walls obstructing the broadcast of the laser beam to the exterior walls, use painter's tape to mark the laser elevation off of the floor onto a door jamb. Relocate and reset the level where it can be broadcast to the mark and the remaining exterior wall. Then finish measuring. Identifying the low spot and installing the sump system in that location will make a Waterguard drainage system work great. If the sump system or Waterguard drain outlet were installed at a high spot, the water would have to fill up the Waterguard before it drains out. And with this water filling up the system, it can cause damp spots on a floor, or worse. If the sump system cannot be installed at the lowest spot, there are a few options. If the location of the sump is under a fraction of an inch difference of the low spot, Waterguard can be pitched from the low spot to the sump location. This way you can make up for the difference. The second thing you can do if you cannot get the sump in the low spot is to install a Waterguard drain outlet at the low spot and run a feed line from the drain outlet to the sump location. We call any pipe that goes from a drainage system to the sump a feed line. Most often, this feed line is usually just a few inches long, but it can be any length. For example, If the low spot was along the back wall where a finished area is, and the sump location was along the front wall, then you could jackhammer a trench across the floor to run a feed line from the low spot to the sump. The feed line can also be run in front of the Waterguard to the sump location, along the same wall. Jackhammer the trench along the wall where the Waterguard will be installed a little wider and a little deeper. Install a Waterguard drain outlet from the Waterguard to the feed line at the low spot and run it to the sump location in front of the Waterguard. When there are multiple low spots, you can add a Waterguard drain outlet and feed line from one of the low spots to the sump location in the other low spot, or you can have multiple sump locations. The second of the 3 key steps to installing a successful Waterguard system is installing the proper Waterguard drain outlet into the sump liner. The drain outlet was specifically engineered to maximize the amount of water that drains into the sump system from the Waterguard system. The drain outlet connects to a 4-inch feed line that makes sure the water drains out fast. Most of the water that runs out of the Waterguard system will go under the drain outlet, through the clean wash stone around the sump, and right through the perforations on the side of the sump liner. That is why, at times, you can look in the sump when the pump is running and not see water coming out of the drain outlet. But that does not mean no water is draining out of the Waterguard system. When there's a lot of water, the Waterguard drain outlet allows water to rush into the sump system for both directions. There are things you could do to get more drainage from the Waterguard system to the sump. You can make the trench deeper near the sump and use a lot of clean wash stone there for the water to drop out of the system and into the sump liner. Or, if the sump location is in a corner, you can break the corner out completely and put the drain outlet on one side and clean wash stone on the other. When needed, install a drain outlet on each side of the corner. Just make sure lots of water can get into the system and into the sump liner to get pumped up and out. The last key step to installing a successful Waterguard system is to backfill the Waterguard with 3/4 inch clean wash stone all the way to the top of the system before you concrete it. It is important to use clean wash stone that does not have dirt or fines in it. This is so we could get lots of drainage and do not add any dirt into our system. If we must put stone behind the Waterguard, like when we go around an obstacle, or if there are crooked stone walls, clean wash stone is used behind the Waterguard. Once we backfill the front of the Waterguard with clean wash stone, we should not sweep dirt into the stone in front of the system. If there was mud in front of the Waterguard where the clean wash stone should be, the water could diffuse through the floor and make the new concrete damp. This is why we use clean wash stone and backfill all the way to the top of the Waterguard, or even a bit higher, so the new concrete does not mush down and get below the top of the Waterguard. Next, install Waterguard sheeting over the Waterguard and clean wash stone. This will reduce vapor transmission from the soils below. Waterguard sheeting rolls are 6 inches wide and 480 feet long, pre-cut rolls made for this purpose. Preparation. As with any installation, preparation is a very important phase to ensure a safe, organized, and efficient installation. Start your day by reviewing the assets for the Waterguard installation, including the proposal, pictures, and any addendums. On FileHive, be sure to download the truck inventory list that shows what the suggested stock is for a production waterproofing truck. The truck must be stocked, and not only with the materials for the pending install, but it should also have a rolling inventory. This way, if there is a scope of work change, the crew has the materials to finish the installation in the allotted time and will not need to return for another day. If the installation is scheduled for more than one day, it is recommended to bring all materials to the job on day one. This way, if things are going ahead of schedule, you will have everything needed to finish up early. Safety. Be prepared with all personal protective equipment to complete the Waterguard installation safely. This will include, but is not limited to, safety glasses, back braces, knee pads, gloves, dust masks, etc. Refer to OSHA standards or your state requirements. Let us review the steps to installing Waterguard. Prepare the worksite. Install the sump system and discharge line. Jackhammer the perimeter trench. Clear out the trench and remove the breakaway. Sweep up and wash down the floor and walls. Install any wall systems and flood test the trench. Install the Waterguard drain outlet, and Waterguard ports. Backfill the trench with clean washed stone and install Waterguard sheeting. Concrete and restore the basement floor. Prep the worksite. With the customer's permission, get the truck as close as possible to the best entry door to the basement. Be sure to install canvas or tarps under the rear bumper of the truck and leading up to the entry door. As the install progresses, debris being carried out of the worksite could topple out. The better we prepare for the work ahead, the easier it is to keep the worksite clean and safe and wow the customer along the way. Dust can be a big issue. Be sure to shut the heating and cooling system off before starting any work. It is recommended that this is shut off with the homeowner there with you. This way, they will know what switch you turned off. If the heating and cooling system is forced air and there are intake and returns, be sure to cover over them with 2mm dust cover plastic and tape it off so no dust or debris enters the system. Having the homeowner lay damp towels over the floor grills upstairs will help control the dust too. Plastic and tape over any carbon monoxide and smoke detectors, as dust may falsely trigger alarms. Cover appliances, any flooring that must be walked over, and cover open doorways to other areas you may not be working in. All customer belongings should be moved to the center of the basement and covered with plastic dust covering before any work begins. Be aware that opening basement windows can draw more dust up into the house by nature of the stack effect. If opening a window, be sure to use a portable ventilation fan to exhaust the air from the basement to the outside. You do not want to use a fan to blow air into the basement from the outside because this will pressurize the basement and blow the dusty air upstairs. This is exactly what we do not want to happen. This can also happen on a windy day outside, which creates a suction in the house that will pull the dust up into the home. Instead, use a ventilation fan to suck air out of the basement to the outside. This way, you depressurize the basement and suck air from upstairs, which is what you want. Beware of the dust on your job site and do what is necessary. Thin or soft floors do not produce a lot of dust when you jackhammer them. Hard, thick floors make a lot of dust. You will be surprised how much dust you can get upstairs and even on the second floor under the right conditions. So, be aware. If there is a dust cloud in the basement, stop jackhammering and figure something out. You can wet the floor, which will help. Hilti offers a dust removal system, the TE DRS 3000, for concrete demolition, which works great with the TE 3000 jackhammer. This system affixes to a mount on the jackhammer, which connects to a vacuum cleaner. The next thing is to bring all material down into the basement needed for the job. Do this first as a team, so the crew does not have to go back and forth to the truck all day. To make the job go faster, we carry 3 jackhammers on the truck. Jackhammers should be stored in your truck upright, not upside down. This is so the grease in them does not run where it's not supposed to inside the tool. If your jackhammer is greasy, wipe it off. They can leak grease or even shoot grease out of the side of the jackhammer when it is running. Service jackhammers as necessary. Be sure to wear safety glasses, safety toe shoes, ear protection, and dust masks when jackhammering. Plug the jackhammer cords into different circuits so an electrical circuit does not trip. Use heavy 12-gauge extension cords. If you use 14-gauge extension cords, you are not getting enough power to the tool, which causes it to lose power and can burn the motor out prematurely. If you must unplug something the homeowner had plugged in to use that outlet, a little trick is to tie the cord from what they had plugged in to your extension cord, and then when you clean up and take your cord away, you will not forget to plug their cords back in. Jackhammering and debris removal. It's necessary to get one crew member to work on installing the sump system as soon as work begins. This is especially important when it is a wet job, so you can get the water pumped out right away. This includes installing all proposed sump systems and the discharge line to the exterior, so you can get the sump pump operational. If it's not a wet job, then later you will need the sump systems operational when washing down the floors and walls. The two other crew members begin jackhammering the perimeter trench. When jackhammering the trench for the Waterguard, open it a minimum of 5 inches wide and open the trench past the footing if possible. If the footing is very wide, jackhammer past it every 6 feet or so. This lets the water in the trench drain down underneath the floor, and if there is any porosity to the soil under the floor, it will soak down into the soil. It also lets water come up from under the floor into the Waterguard if needed. If the floor is very thick, you do not have to go all the way through it. For example, if it were 8 inches thick, you can go down 5 inches or so, but it is a good idea to go all the way through the floor every 20 feet or so. If the footing is high and you need to notch it or take an inch or two off the shoulder of the footing, then do that if you are not breaking through the footing straight through, just chipping the shoulder lower to get the Waterguard in. As a rule, the deeper the Waterguard, the better. In instances where the floor is extremely thin and the footing is just below the floor, an option is to use the Waterguard Flex system, which is a combination of flow guard and flangeless Waterguard. Flangeless Waterguard is just like it sounds. Its shape is nearly identical to Waterguard, however, it does not have an integrated wall flange. Available in 2 sizes, we have a standard flangeless Waterguard, which is 1 7/8 inch tall, 3 1/8 inch wide, and 7.5 feet long. We also have flangeless Waterguard XL, which is 2 1/8 inch tall, 4 inches wide, and 7.5 feet long. In order for flangeless Waterguard to capture water from leaking walls, like Waterguard would, an additional product called FlowGuard is installed. Available in 2 options, FlowGuard and FlowGuard SS, FlowGuard reintroduces the wall flange to the flangeless Waterguard perimeter drainage system, allowing water from the wall to communicate with the flangeless Waterguard that is installed below the surface of the basement floor and in front of the footing. FlowGuard is 7.5 feet long, 3 inches tall, and 4 1/4 inches wide. In homes where the footing is lower, FlowGuard SS is installed, which has an additional 1-inch spacer added on the footing side of the product. FlowGuard SS is 4 inches tall and 5.5 inches wide. Now it is time to clear the rubble. Use a mattock to clear the broken rubble from the trench and pull it onto the floor. Then use a flat shovel to get it off the floor. Managing the rubble can be done with 5-gallon buckets, 10-gallon mini brutes, or 35-gallon brute garbage cans. Depending on how the crew is going in and out of the basement, can determine what size buckets or barrels are best to move the breakaway to the truck. If you are using 5 or 10-gallon buckets, you can carry them to the truck and dump them into the 35-gallon garbage cans. Do not sweep the fine stuff into the trench. Use this opportunity to sweep the walls down too. If there's any loose debris on the walls, sweep it off now. Be sure to keep all garbage separate from the rubble. If the basement has block walls, the next step is to drill weep holes. Using a 1/2 inch or 5/8 inch masonry bit, drill 1 hole in each core of every block. Be sure not to drill through the entire block to the outside. Our goal is to only drill through the interior face of the concrete block. When you are drilling, you will feel a pop as the bit passes fully through the front face of the block and enters the hollow cavity. Do not drill any further. This weep hole is meant to drain any water that may be inside of the blocks. If it is a 2-cavity block, then drill 2 holes. If it is a 3-cavity block, then drill 3 holes in each block. Drill the holes below the floor level so they will be covered up by the Waterguard. If you drill the holes and the drill bit does not pop through the hollow cavity of the block, then you will need to drill the holes higher up until you do pop through the block. Sometimes the bottom course of block is filled solid on purpose, or there's just mortar droppings from when the mason built the block wall. If you must drill the weep holes higher than the floor, then you will need to install clean space or strips of bright wall to cover the weep holes. This will properly channel any water that comes through the weep holes down into the Waterguard drainage system. If you drill weep holes and mud or sand or vermiculite starts coming out of the block, the problem is there could be a hole or a crack on the exterior of the wall, and as the water enters the block, it brings the sand or mud with it. If we drill the weep holes and this starts to happen, as the water comes in, and will continue to come in, this will eventually bring mud or sand down with it and clog the Waterguard system. So, if you drill weep holes and mud or sand comes in, along that wall we want to plug up those weep holes that we did drill and install the system with no weep holes at all. Now you may find that mud and sand is coming in on one wall only. Because we are not relieving the water that is in the wall cavities in that section of the job site, we would want to go ahead and install, at minimum, 2 feet of clean space or bright wall, but a full wall system is best. You can add a Waterguard inspection port to monitor the Waterguard system in the future. The next step is to wash down the floors and walls and flood test the system at the same time. Sweeping is not enough to clean the floor. If the floor is dry, there will be fine dust on the floor after you sweep. If the floor was wet, there will be a pasty dirt and concrete mixture on the floor that sweeping can just not get off, but it smears around instead. So, use a garden hose to wash this off the floor and spray the water into the Waterguard trench. If necessary, another crew member can use a broom and sweep the water towards the trench so it does not run to the center where you have all of the homeowner's belongings covered up. Take this opportunity to wash down the exterior walls. Also, take this time to clean basement windows, sills, sewer pipes, oil tanks, the water tank, and so on. Please use caution and do not spray down the electrical panel or near anything electrical. Another very important thing you are doing at this point is flood testing the system. But the system is not installed yet, you say. Well, it's the trench that is doing the work of draining the water to the sump system. If the trench drains to the sump location without filling up close to the surface of the floor, then your system will work the same way once you install the Waterguard system. If there is a problem with the trench draining, you will have the same problem when the Waterguard is installed. So, it's best to find out now, because as you know, water is the ultimate level. Fill the trench up with water, opposite the sump location, and see what happens with the flow. If necessary, you can get the jackhammer out again and make the trench a little deeper where needed to make it flow perfectly to the sump. Since every system is flood tested like this before the Waterguard system is put in, we are never surprised by any flow issues in the future. Next, flood test the sump system and discharge line, inspecting each plumbing joint on the discharge line for leaks after the pump is run a few times. It's better to find a leak now than to have your homeowner find a leak later. You can also see what is happening with the water where you ended the discharge line, and make any adjustments outside. Leave the hose out to mix the concrete later. Install wall systems. If the proposal on your job includes a wall system, install the bright wall, clean space wall, thermal dry wall, Fomax, or Zen wall now, so the Waterguard can be installed against it, because it is hard to get a wall system tucked in behind the Waterguard later. Make the wall material go down below the floor level, no more than 2 inches. This is so we do not cover the perforations in the Waterguard. Install a Z-channel as needed. A Z-channel is installed to direct any wall leaks down behind the integrated wall flange on the Waterguard. Now we are ready to install the Waterguard in the trench. If you have scraps of Waterguard, use the scraps first coming out of a corner. Full Waterguard lengths are 7.5 feet long. Use the pre-molded Waterguard corners or Waterguard corner ports where 2 walls intersect. Waterguard corners are inside corners, and when you flip it over, it's an outside corner. Cut all the Waterguard pieces to length. If the wall has a bow in it, you can make a relief cut or cuts to the Waterguard so it can conform to the shape of the wall. If the wall bows outward, cut a relief in the back of the Waterguard. If the wall bows inward, cut a relief in the front of the Waterguard. Do not cut into the wall flange. If there is an extreme curvature to the wall, cut V notches as needed. You will use Waterguard tape later to cover your cut. Next, set the height of the Waterguard in the trench. Use a straight edge off the existing floor to determine how much of the Waterguard's wall flange will be exposed after the floor has been restored with concrete. This allows us to set the depth of the water guard within the trench. Take your clean washed stone and push it under each end of the water guard until you have reached your desired height. Typically, the wall flange will be about 3/8 of an inch above the existing concrete slab. Continually use your straight edge to check the height of the existing floor in comparison to the wall flange. Install a Waterguard inspection port or Waterguard corner port in the furthest opposite corner from the sump, or as far away as you can get away from the sump location. It is recommended to install a Waterguard inspection port every 25 feet or so. If installing a sand and dry away from the sump location, you will need a Waterguard inspection port there to drain the unit. A Waterguard inspection port has a knockout to accept the drain hose from the sand and dry basement air machine. Waterguard inspection ports are great to inspect the Waterguard system, and they provide access points if you wanted to flood test the system. In areas where oil is used to heat homes, most commonly the oil tank is found in the basement. Take care to observe if the oil supply line from the oil tank to the furnace is above or below the basement slab before jackhammering the slab, as you do not want to damage it. In this example, the oil tank is directly against the wall. Because we cannot get a jackhammer to the floor wall joint, we opted to put the water guard in front of the tank. If the oil tank is positioned far enough off of the wall to work, use a jackhammer and put the water guard behind it. Sometimes, if the tank is off the wall but space is limited, you can even use an extension bit with a rotary hammer to open the trench behind the oil tank. Ideally, the water guard system belongs at the floor wall joint, so if it can be installed that way, do so. If you do need to go around an oil tank, the concrete on the edge of the trench will be jagged. You can use a modified piece of cactus board to cover the broken edge and give a nice clean finish. When you approach a water line or sewer line in the process of opening the trench, stop jackhammering on either side of it. Use a Hilti rotary hammer with a chisel bit to remove the concrete directly in front of the obstacle. This way, you can visually inspect underneath the floor to determine if you can install the water guard at the floor wall joint by simply notching this section of water guard, or you can use water guard corners or trench drain and box around it. Trench drain is a linear channel with a U-shaped profile that is covered by a drainage grate. A trench drain is installed flush with the basement floor at the foot of an exterior stairway that provides access to the basement from a leaky bulkhead or a hatchway door. It is recommended that trench drain is installed on the inside of the doorway because we do not want to introduce dirt and debris from the oftentimes inadequate existing hatchway door. Also, cold air from outside can blow into the grate and come into the basement, so we just avoid installing trench drain outside. Be sure to extend trench drain a few inches past the doorway threshold and flush with the basement walls. This way, we will capture any water infiltration from the entirety of the bulkhead area. When installing trench drain, we abut it to the water guard and tape over the grate, so we do not make a mess of the channel when installing the concrete. We also tape the sides of the channel to the water guard, so no concrete or clean washed stone will fall into the trench drain. Remove the tape once you're through with concreting the trench. Trench lock comes in 24-inch lengths with a ball and cup design to let water drain down, meanwhile preventing cold air or radon gas from coming up from the otherwise open channel. Simply cut the trench lock to length and caulk it in place with flexi-caulk. Place the balls in the cup assembly and put the grate on top of the trench drain. Waterguard drain outlets can be installed in two ways. One way is to cut a 7-inch notch out of the water guard and sliding the drain outlet over it. You can also insert the water guard lengths into the left and right sides of the drain outlet. Be aware you must keep both lengths 7 inches apart from one another. Our sump liners have a pre-cut 4-inch knockout that's meant to receive a 4-inch PVC feed line from the Waterguard drain outlet. Install a 4-inch feed line through this knockout and connect it to the drain outlet. Always use a 4-inch PVC pipe when connecting the liner to the drain outlet. Cut excess 4-inch PVC piping from inside the sump liner so there's only 1 to 2 inches of pipe protruding into the liner. Most often, this allows the water to drain down inside of the liner for a quieter system. Also, this limits cavitation. Cavitation is the formation of bubbles in a liquid. This lessens the chance of a pump becoming airlocked. Next, tape all butt joints to keep concrete out when restoring the floor, so no concrete enters the Waterguard channel. Using 3/4 of an inch clean wash stone, backfill all the way to the top of the Waterguard, or even a bit higher, so our concrete does not mush down into it and then get below the top of the Waterguard. Install Waterguard sheeting atop the Waterguard and stone. Next, we need to mix the concrete. Concrete is the proper term. Concrete is made of Portland cement, aggregate, and water. Therefore, cement is part of concrete. We do not use stone in our mix, so it is easy to trowel. The sand is the aggregate. So what we use can properly be called concrete. When mixing concrete, make it stiff, because wet, soupy concrete will be very weak, and in the end, it will crack more and it will shrink more. Stiff concrete, like cookie dough, is best. Most mixing instructions say for every 80-pound bag of sand mix calls for 4.6 quarts of water. That is 1.15 gallons. We trowel the new concrete with a steel trowel. Troweling is an art that you will get better at with practice. When leveling the new concrete, use the existing floor as your guide so that your new concrete is flush with the old surface. At minimum, we recommend at least 1 inch of concrete atop the Waterguard system, although 2 inches would be better. Now, the Waterguard installation is complete. Cleanup. Remove all excess materials from the basement. It is best to leave some tools just outside the exit door, so if the customer has a concern and you need to make a minor adjustment to the installation, they are readily accessible. Complete a final cleanup of the work area. Remove all plastic from the customer's belongings, ductwork, carbon monoxide, and smoke detectors. Turn the switch back on for the heating and cooling system, and be sure that the basement is cleaner than when your crew first arrived. Be sure to clean up outside and by the back of your truck. Let us review the steps. Prepare the worksite. Install the sump system and discharge line. Jackhammer the perimeter trench. Clear out the trench and remove the breakaway. Sweep up and wash down the floor and walls. Install any wall systems and flood test the trench. Install the Waterguard, Waterguard drain outlet, and Waterguard inspection ports. Backfill the trench with clean wash stone and install Waterguard sheeting. Concrete and restore the basement floor. A 3-man crew should be able to do 120 feet of Waterguard and a sump system in 1 day. Of course, job conditions and the scope of work can vary. We have had jobs that took twice as long as that, and others where we have done over 200 feet of Waterguard in a day with just 3 men. Installing Waterguard is common sense. Water flows downhill, so all we need to do is make a trench around the perimeter of a basement floor, catch all the water from the floor wall joint and the walls with Waterguard, and drain it to the sump locations.